Welcome everyone. Welcome back to Reliability BoomBox, where we talk all things reliability engineering, maintenance engineering, mining production, and all things about that sort of space. So let's get into it. Welcome again, Seven. Nice to see you and have you here.
Oh, thanks, Dane. Great to be here.
All right. Last week we kicked off with having a little chat about what is RCAs, or root cause analysis, problem solving, as we like to talk about it. And we also talked about what is machine learning, and just a little bit of what it's about and from your perspective. So tonight we're going to kick straight into it, and we're going to talk about why. So why is it important? First up would be my question. Why is it important that we do look into problem solving? Let's start with the problem solving one tonight.
Yeah. So around having a formal process around your problem solving, why do you want to do that? And the simple answer is to nail the answer. Mm-hmm. Okay. To nail it consistently.
Yeah. And
to provide the outputs in a consistent format that everyone can understand. And obviously it's all about doing the right things at the right time. Okay. If you start missing answers, i.e. you don't get the solutions that solve the problem, okay, you're not doing the right things at the right time anymore. You're doing something at time, maybe at the right time, but is it the right something? Okay. So you want to hit the nail on the head. So it's getting that probability of doing the right thing at the right time right up there as best as you can, especially if we're dealing with assets or pieces of equipment that are worth millions, if not billions of dollars.
Yeah, awesome.
That's why you want to do your problem solving.
Yeah. So we've all been in the analogy. I think we talked about it last time. Like, we can find a problem, we have a problem, and we can be like a shotgun and just go out and try and fix it straight away. But without having too much thought behind it, without understanding what the problem is, we can't really understand how to fix it, which highlights the reason why you want to actually have a problem-solving method or a process that you actually follow that standardizes that, so that you can really get down to answering the true question, understanding truly what the problem is.
Absolutely.
So, understand.
Yes. Well, that happens to be habit 2, isn't it?
Yes.
Habit number 2 of the 5 habits.
Jeez.
Awesome. Who did that?
Who did that?
Who did that?
Yeah. So,
but it's relevant.
Yeah, totally. And I think it is important that we do understand, what information is there, what the problem is in problem solving, what potential causes you have, what potential solutions you have, and then you can really nail down on the why you want to follow through. I think sometimes, and I'm just flying with it at the moment, but I think sometimes we come across problems and we think, oh, we got to fix this problem, we've got to fix this problem. And then when we really understand what the problem is, sometimes we also don't need to fix it. There might not be a problem. It might be something that you, in machine wise, you might go, well, we can turn that off, or we can do without it. And so when we do understand and what the problem is, what the machine does, and we can solve the problem, and we have the right things at the right time, like you've got written there.
Right things at the right time.
Right things at the right time.
That's what it's all about.
And following that process helps to find that why. So awesome.
Yeah. And some of the problem-solving processes actually lend themselves for some very creative solutions and out-of-the-box thinking. Now, if you follow the process, for example, Sologic, it sort of leads to potentially some very creative and innovative solutions, and actually lead, and it can lead you in some really, like, I've seen some simply brilliant ideas come from people when you sort of use a formal process, i.e. they know what's coming and you've got some steps to follow. And that's what we're talking about, is just some simple steps to follow, one by one after the other. And so you're not, what you need to do to, as in the process, to solve the problem, you just get along and solve it. And then that what would you call it, mental load is removed, because you're simply following some steps in the process, and that creativity starts to come out, which is awesome. And I feel like I was probably stumbling along my train of thought, but you've kind of helped pull it back together, which is great. Because it's that creative thinking that as a business and as an organization you want to see in your team, or you want to have in your engineers, that actually think outside the box to create things better. Sometimes when we actually have a problem, it's a good opportunity to make a major improvement on the whole plant, on the whole piece of machinery, on the equipment that we have. Exactly. And if you're presenting the results in a format or a way that everyone gets and understands, and say, this is what we, this is the way that we communicate how we're going to solve this problem, right? If everyone's doing a similar method and producing a similar results, and people know what to expect at what point in time, if they're, say, reading a report, it just gives them that much more brain space, i.e. more capability of understanding what you're trying to say and what you're recommending, or what we need to do, rather than trying to figure out what this person is saying, because you know the steps. Again, it's that advantage of that formalized problem solving process. You're not working on the actual process itself of solving the problem. You're just getting in and solving the problem, and giving, putting basically all of your energy into that, and not diverting any energy into working out a process, because it's all defined for you. And I just thought of a little analogy popped into my head as you're doing it. And as we know, I love analogies. Yes, you do.
It's a little like driving a car. Like, if you're driving a manual car and it's your own car that you've driven every day for 10 years, then you're very familiar with it. You know where the gears are, you know how hard to press the clutch, and when to use the gears to slow the vehicle down well enough. Well, if you then go and jump in someone else's car, and it's manual too, but it might be a little older or a little newer, and all of a sudden there's a whole lot of other things to think about. Driving becomes a little bit more challenging. Fortunately, if you're still driving in the same country, on the same side of the road with the same guidelines, then it's only the car that you're actually thinking about. It's only, apart from where you're going, obviously, but it's your main concentration is finding those parts of operating that vehicle. So it's the same sort of thing in that problem solving, that you've got the road, you've got the guidelines, you understand there's a giveaway sign, I need to go there, or there's a question, there's a why, there's a cause, there's a potential solution, this is where I go. But you get to come back into the type of vehicle or the piece of plant that you're looking at, and just focus on that and find the opportunities within that to improve.
Yeah. So no, I totally agree. Having been in my corporate life, solved quite a few problems over the years, having a process to follow just makes it that much easier. You just, the stress comes off your shoulders, because you're just going to follow the steps and trust the process.
Totally.
Work on the book, not the process.
Awesome. So
problem solving, that is.
That is problem solving.
That is problem solving.
So moving along to machine learning. Why machine learning? Now, like we talked about last week, it's a bit of a new thing about the industry, especially for us in Australia. I know in the United States and maybe in Europe and so forth, they're a little bit more familiar with it. And look, we'd love to hear from anyone that has some viewpoints on this, because it is newer to us. But in your opinion, why is machine learning such a valuable tool? And I like the idea of tool because it's another thing that we can put in the toolbox. It's another option that we can have.
Totally agree. Machine learning as a tool. Why would you want to pull that tool out of your toolbox?
Yeah.
Very, very, I can actually say it in 2 words. Lead time.
Yes. Okay.
Lead time, or maximizing lead time. 3 words. I've got 3 words, mate. Maximizing lead time of an impending problem. Okay.
Right. Yeah.
So it is a tool in the toolbox. It's not the end all and be all of everything, and solves everything from ingrown tailnails to $12 billion plant failures. It is a tool in the toolbox, okay? And there's certain overheads. Obviously, with any tool that you use, there's a weight to a spanner or a wrench, and it depends which one you pick up. And again, it's all about maximizing lead time and giving the advantage to that to engineers, or reliability engineers in this case, is that if you have sufficient lead time, or the maximum amount of lead time possible, you can plan in the repair in an opportunity. So let me draw a picture. Okay, so if this is a planned repair, okay, at this point in time, so this is like time along the bottom here, right? If we know about this impending failure here, I've got a very good chance of actually scheduling it into the planned repair window, okay? Now, if I don't know about that and I don't do anything about it inside my planned repair window, okay, there's, we're not seeing any symptoms that a human would recognize, hence the machine learning. So we're not seeing any symptoms that a human would recognize, and we have a planned repair and we miss it, okay? Obviously, we might have, levering off the Reliability BoomBox title, we'll have a boom after the planned repair, okay? Yeah. Obviously, we're trying to eliminate the booms, okay? Yeah. We're trying to eliminate the booms, and the more lead time, and the lead time in this case is actually from here, that's where the boom occurs. So the lead time is here, and optimally, we want enough lead time using your machine learning tools to get it into a window of opportunity where you do a planned repair. So that's why you should look at it. It's a tool in the toolbox to give you lead time that a problem is occurring, or about to occur. Sorry, a problem is about to occur, and to get those repairs into a planned repair window with sufficient lead time.
Yeah, awesome. I think too, one thing that came to my mind in that, and I certainly agree, and I certainly see the value in having that lead time to, make the repair before we do get the boom or see the early signs. I think too, from a business perspective, let's say that you have that there is a potential failure, or there start to be signs of a potential boom, and it doesn't get captured. So you're not using machine learning. It doesn't come up, and you're in that imminent space of a potential boom. You might land in that planned repair time, and it might actually get picked up at that planned repair time. But that planned repair window might only be 12 hours, 1 shift, 2 shifts, or even just a week. However, that work wasn't scheduled for that period, for that planned time. And as we all know, with our society and the way life is and the way the operations are and production industries across the world are, those windows are so tightly jam-packed with things to be done that any extra screw that needs to be tightened, any extra bolt that needs to be undone and then redone up or changed adds time to that. So then you actually have an overrun cost. And that means that the machine, it might take, instead of the 24 hours that it's planned in, it might take 36 hours to get repaired and back in so that you prevent the boom, which is great that they've done the work to prevent the boom and you've got suitable staff out there to pick up these things. But that's an extra 12 hours that you weren't expecting to do that.
Yes. Yeah. Exactly. And some people actually track that. But why is the outages so jam-packed? So if I ask that question, and it comes back to one of the fundamental reasons why we have reliability engineers. Okay, and the answer to that question, the question is, we are trying to get the most out of something, costing the least when we're finished with it. Okay, so and that's the whole idea of business. Is you've got some sort of asset, and you're trying to maximize its output, costing you the least, right? And you're constantly striving for that. That's the way it works. Why would you spend $12 billion on an asset? Okay, it's one of the assets that I'm involved in, that I help out with. Why would you spend $12 billion on an asset and not use it? Makes sense. It's not, it doesn't, your shareholders would be very unhappy if you did that. So that's what the whole idea of reliability is all about. And if you, hear me speak about the book or at conferences, and I generally lead in with that obviously we are trying to maximize the output, costing the least when we have finished with it. Okay, so the three arrows. So maximizing your output, whatever the outputs are, minimizing inputs. Yeah. We're over time, or when we've finished with it, right? So when we're finished with it, that's where we want to be. We want to be able to say we've really got our dollars worth out of this piece of equipment. Yeah.
And so one other thought that just sprung to my mind in your conversation there, and please correct me if I'm wrong, it's more of a question, but would machine learning, like you said a second ago, in these outages, in these planned downtimes, we jam so much in. There's so many things that we need to do, and it's because we're trying to maximize the output in minimum time. So we're doing as much as we possibly can. Once we start to understand the machine, once we start to operate or use this machine learning tool a little better, would we be able to optimize what gets done in that planned outage? Would we be able to look at certain things, and like we have our standard sort of maintenance strategies, but from my experience, these planned outages go, okay, we've got your oil and lube change. It's a basic 250-hour maintenance. We're going to do these things. But could we look at this and say, well, obviously we're still going to do 12 hours of work.
Yes.
But because the machine's running really well in this case, and not so well in this case, instead of doing that particular lube change because we've got an opportunity to do that in a week's time and we'll be okay, we're going to do this work instead and still bring it into that 12 hours.
Yeah. The answer is yes, it is helpful in making those decisions. And the reason for that is that you can set up your machine learning to recognize specific problems. Okay. So if you've suffered a problem, and I'll use the analogy as in a person, right? We've learnt that, okay? We've learnt with these symptoms, okay? So I'm going to draw my little boom, right? There's our little explosion here. It looks a little bit like a tree, but it's actually it's a boom, like it's like a nuclear explosion, right? Okay. So people draw this thing, the predictive curve, and they typically talk about the PF interval, and we are talking about the PF interval. And if we're talking about a bearing failure, you know, the first thing we see is vibration.
Yeah.
Right. And then next thing you might see a bit of heat, noise, like I'm talking from a textbook, right? And then obviously we get the functional failure where we actually have the boom. Okay, so as we go along, we can actually teach. Okay, we can actually teach a machine learning algorithm, or an algorithm, or a bot, or whatever you want to call them.
A lackey, a supervisor.
A lackey, a supervisor. that this particular vibration signature, because it's seen it before, right, leads to this particular boom that's about to occur. So if you've got a list of jobs to do, 1, 2, 3, and 4, okay, and our machine learning over here on the side now says, oh, hold on guys, you've now got job number 5 to do, because we are now inside the PF interval, and we know this distance here, i.e. you might have, say, 10 days lead time. Mm-hmm. That's not unreasonable in some of the machine learning algorithms that I've seen and been involved with, right? We know that we're going to have this occur in 10 days' time. And because it's happened before, we know the effect of that failure. We know the effect. Mm-hmm. Okay. We now know the size of the jobs that we've currently got planned. We can choose where we're going to put job number 5 in, and we may choose to put job number 5 in right here and drop number 4 because it's a lower priority. Yeah. Okay. It's a lower priority. The boom that 4 prevents is smaller than the 5. That's what I'm trying to say. Okay. So it's all about risk and managing risk of failure in this case, and you know, and it's all about maximizing effectiveness.
Yeah.
Okay.
Yeah, and I think that's a really good example. I'd like to just lead in with that. Often when we get new ideas, new concepts, and machine learning, or problem-solving tools, and things that are happening with software and the likes of AI, as humans, there's a natural tendency to sort of back up and go, "Ooh, what's going on?" And maybe it's an Australian thing, but people go, "Oh, are they trying to do my job for me? Hang on, that's my job." Like it's a reliability engineer's job to do this, to see these things. However, as we discussed last week, and it's something I really want to keep bringing to the table, and just as a really kind reminder, is it's a really useful tool. It's a tool to actually help you do your job better. And I'll use the analogy of cutting large cables. I'm an electrician by trade, so we used to cut really large, 200 square mil cables with a hacksaw, and take you an hour of cutting it. Now they've got large hydraulic crimpers that cut it in 2 minutes. It's a tool that just makes your job easier. It's not to say that you can't do it anyway, but it actually makes it easier. And as we discussed last week, that in a lot of these situations, as reliability engineers, we're looking after so many pieces of plan, we're looking after so many pieces of infrastructure, or there's such a large array of things that we've got to look at, that to keep on top of all these things, like you'd have to be looking at the data for the vibration analysis and the condition monitoring of that piece of plant on that bearing 10 days in advance, and have seen that very small signature vibration come up to go, there's a vibration. That doesn't usually happen.
Exactly.
And you got to be on it. So as soon as that report gets in, you've got to be there, sitting there looking at it going, I've got it. But we don't all have time to do that. We usually get a Kanban report and we'll scan over it, and then we'll look at it again in a week's time.
Exactly. Well, just talking about that, if you want, I can talk to an example that actually occurred today, where on a certain brand of mining truck, Okay,
Yep.
It's known to have an issue with wheel bearings. Okay, and
right.
the task is to they generally come with a magnetic plug that you can look at. Okay, so you've got a magnetic plug with a screw thread, and what happens is that stuff gets on the end of the magnetic plug, as in metal, to tell you that your wheel bearings are going to break. Okay, so experience. Now, experience, okay, experience is very valuable. Experience value tells us when you see stuff on the Maggie plug, okay, it's too late. They're gone. They're dead. You're dead in the water. You've got to repair them now. Okay, because you send it out, it will be back with a wheel bearing problem. Okay, so what these people did was they used machine learning on their oil samples. Okay, and the machine learning was picking up subtle differences. Okay, that a human would very hard to see, but subtle differences. You could trap it with a standard algorithm, I do admit that, but here, the machine learning algorithm was picking up the subtle differences in the oil analysis reports. And if you do what you just said, Dane, is breeze over it, so the oil sample lab won't pick this up because it's not going across some sort of threshold. Like it's not going what the machine learning is doing is picking up on really subtle, okay, increases. Your target might be up here, and all it's done is you've got a baseline, and now it's starting to go up. That's what the machine learning is recognizing. Okay. Yeah. Awesome. And so it's recognized it, and say the failure occurs here. Right. There's a different shaped boom for you. What they found was that the machine learning was picking it up about 18 days beforehand.
Wow. Awesome. Yep. So if you were to extend that curve up till you get to your target points, it's probably happening around that boom time.
Yeah, exactly.
And
exactly. You got
so if you're talking oil samples, it might be a measure of microns of particle matter or something like that, and it's able to pick up a smaller volume of microns in there a little earlier and flag as a warning. With what is it? 1 or 2 days. Awesome.
If I change color here, I know I've got my scribbles happening here, but it's the subtle changes that the machine learning's picking up. Yeah. It's the subtle changes. I'm going to use the words difference in behavior. It's the subtle differences in behavior, right, that gives you the early lead time of symptoms. Okay. Awesome. And if the machine learning goes, I found a problem, so my bot's barking up, going, there's a problem here, and you go, well, I'm not sure about this. What are you seeing? The good ones tell you what it's actually seeing. Yeah. The good ones tell you what it's actually seeing. It's not just telling you what a problem is. It's actually saying this parameter, this particular parameter is behaving differently to what I've seen before. Okay. And then if in doubt, in this case, take another oil sample, run it through again, okay, and see what the machine learning says. And look at it yourself and say, ooh, that's very interesting. And if the next one is up here, you've got a problem, and you might be 12 days out. Yeah. It might have taken you 6 days to turn around from 18 when it first went off to get that work turned around, but you're still ahead. You are still ahead. And I think that's of that one there. Yeah, another lead into why machine learning is a valuable tool, because in that example, if you've got 18 day lead time to your boom, to your potential boom, it's not that we have to quick pull the brakes, park this machine up and get it fixed. It's okay, we've got some time, we've got a window of opportunity to assess and deal with the problem better. Like if you found that bearing in 1 or 2 days time, you are like, okay, we've got to pull this machine in. And it's firefighting. It's putting out it's firefighting.
The fire.
Exactly.
Whereas you've got, I've got 18 days. Yeah, that's just over 2 weeks. A bit over 2 weeks, 7-day working days probably. So we've got the time now to slot it in, or to do another little check, or change the strategy some way so that it does get repaired or does get fixed, or we just prevent the boom. It's not necessarily fix it straight away. Maybe just understand a little bit more.
Yeah, you've got options. You've got options. Now, I'll tell you a story. When I was in my corporate life, we suffered a big failure on a pretty sort of big piece of kit, big piece of plant. Okay. And it's actually one of the stories out of the book. And what happened was that I was the maintenance manager in this case, and we're in all sorts of pain, right? We had 2 things broken, and it was getting CEO attention and all that sort of stuff. And I went to my boss, and I said, "Boss, what do you do in this case?" And he said, "Seven, all you can do is spend."
Yeah. Right.
Just get the money to spend. Like we had contractors in, we had people from all over the place coming in. It was like the ants running all over the plant trying to get this thing going again. Okay.
Yeah.
So when you're in that situation where you've had a break, all you can do is spend to fix it, right? You're in. So you're just burning the money out of your bank balance. Okay. Yeah. With lead time, you've got options.
Yes. Yeah. Yeah. You're not in that mad flurry to figure it out. Can use my own example. We, my family and I are traveling around Australia in a bus, as you know, as more of you will get to know. And we had a similar situation in that we went away for a honeymoon. We'd bought the bus. We'd started doing some work on it. We'd gone away for our wedding anniversary. And then we sold our house. And all of a sudden we had, I think it was like 10 weeks, or it might have ended up being 12 weeks before we're like, we've got to be living in the bus. And we had to get kitchens made. We had to get toilets. We had to design the bus. Like we'd sort of just started figuring it out. And the only options we had was to really spend extra money than we planned or budgeted for to get it done so that we could live in it.
Exactly.
And with that lead time, with that preparation, with that ability to plan, we could have done things differently, thought it out a little bit more, saved ourselves some money, got things right the first time instead of the third time.
Yes.
And yeah, it either way, it comes down to a saving of time and money, which really, really highlights the importance of machine learning, getting it back to machine learning, in just that, as you said, extending or maximizing the lead time. Maximizing the lead time. That you can actually work on that. And I think, as we like to highlight, the brilliance of both these tools put together in your own little toolbox is, if you do come up with a potential problem and you have a lead time of 18 days or 10 days or even an extra 3 days, if you don't know the solution, you've all of a sudden got more time to solve the problem.
Exactly.
And so you can then go and apply a suitable problem-solving method without the stress of it being in a fire situation, to be creative about the solution and find a more suitable, sustainable solution rather than...
That's the word I'm looking for. Sustainable. I love that word.
Rather than firefighting, I've got to put a Band-Aid on it.
Exactly. I've got to do it. I've got to get it going.
Yeah.
Right? The boss wants it going.
Yeah. Yeah.
That's what you do. You get what the boss wants you to do. Get it going. Yeah. Right? And he doesn't really care, because it's stopped, whether it goes for 5 days or 10 years.
Yeah.
He just wants it going.
Yeah.
Yeah.
Get it going. Yeah. He'll care if it only goes for 5. He'll care if it only goes for 5 days, because he'd be like, "Didn't you fix this already?" But
it's another problem.
It's another problem. So awesome. Well, I think just wrapping that up there, I think it's nice to see that we understand why problem solving really allows us, and having a solid method allows us to be creative in the problem solving process, allows us to find solid solutions that will actually work. and having
do the right thing at the right time.
Right thing at the right time with a good understanding of the process. And for machine learning, it's maximizing that lead time, giving yourself more time and space, and again, more brain capacity to actually solve the problem or to fix it, than that mad rush sort of thing. And as we all know, we live in such a fast-paced lifestyle that any opportunity to get a little bit more space to breathe and think and actually work through a problem is always beneficial.
Absolutely.
So with that, I'm done. I don't know if you have anything else you'd like to share on that, Seven.
No, I think I'm done for tonight, mate.
You're done? You're good?
Yeah, I'm done too.
Awesome. Well, thanks everyone. If you like this, then smash the like button, subscribe, share it with your friends, send us a review on anywhere that you listen to this on podcasts or so forth. It just helps us get the message out there. And as we've said, we just want to help you do your job better and help you with some tools and information. If you have any questions, queries, you can hit us up at reliabilityextranet.com or leave a comment down below. Thank you.